So I have a sequence here for us to look at, and we want to talk about whether or not this converges, and if it does, what it converges to. So this is actually kind of an interesting sequence because if you look at the two individual components, individually, each of those sequences diverges. We saw in the lecture that B sub n diverges, and you can use a practically identical argument to show that C sub n diverges, right? But when you add them together, here's what's going to happen, right? To determine convergence, we need to take the limit as n approaches infinity of the nth term of the sequence, which is this limit here. Now, what I'm going to do next is I'm going to take that first term, the n plus 1 term, and I'm going to split it up. I'm going to make that negative 1 to the n times negative 1 to the first, just high school exponent rules. Now I'm going to take this negative 1 to the n that each of these terms have in common, and I'm going to factor it out. Right? The limit stays the same. We've got the negative 1 to the n out front, and now look at what's left inside the parentheses. We have negative 1 to the first, which is just negative 1, plus 1. Well, that's 0. Right? So this is the limit of negative 1 to the n power times 0, which is just 0. And as we saw right earlier in the lecture, the limit of a constant is a constant. So it turns out that not only does this sequence converge, it converges to 0. Okay, so the takeaway here is just not to make assumptions. Sure, we've seen that if the sum of two convergent sequences converge, but the inverse of that, as we saw right here, is not true. The sum of two divergent sequences, well, it could go either way, right? They could diverge or they could actually end up converging. So if you'd like to get the full context, you can click on the link here to see the lecture I was referring to. And if you like this example or found it helpful, please go ahead and click on the like button down below.